Okay, for sensors and controllers, okay, what is agriculture sensor? So agriculture sensor is any sensors that is used in smart farming or precision agriculture. So these sensors provide data which assist farmers to monitor and to optimize the crops by adapting to changes in the environmental conditions. Okay, so these sensors are installed on weather stations, drones, and robots used for agriculture industry. So the uses of agriculture sensor, okay, here is two example. Yield monitor system and then evaporative control weather system. Okay, for yield monitor system, this example is very common because this system for combined harvester is using both sensors and controllers. Okay, so we have three functions of the system. Okay, number one, sensor to measure the amount of grain and other products that passing through the combined harvester. We have four different types of sensor to measure the grain, which is impact or mass flow sensor, weight based sensor, optical yield sensor, and then G-ray sensor or gamma ray sensor. Again, and then second one, this combined harvester also have sensor to measure the moisture of the grain and other products. Okay, it is very important to measure the moisture of the grain, especially for storage, and also the moisture can be an indicator to see or to know if the grain is actually ready to be harvested or not. Okay, and then number three, controller, also known as a header switch, okay, which automatically turns off the data collection within the yield monitor and when the head of the combine is lifted up. Okay, and then for second one, we also have evaporative control weather system, where the system also have sensors and controllers, okay, which can use to control and monitor the microclimate conditions in a greenhouse. Okay, so the sensors involve, for example, rainfall, wind speed, and humidity. So some of the sensors can be controlled using mobile apps or wireless connectivity, using Wi-Fi or through cellular towers with cellular frequencies with the help of mobile phone app lah, okay, for controlling. Okay, tools number three, okay, remote sensing. So by definition, remote sensing is the science of obtaining and interpreting information from a distance using sensors that are not in physical contact with the object being observed. Okay, it's a non-contact method to collect, to assess, to monitor the object. Remote sensing can come with different platforms, okay, as the figure, as you can see. Okay, they have a space, okay, and then for low middle altitude airplane, and then for ground troop. But basically there are three broad categories for remote sensing platform, okay, which is ground based, airborne, and satellite. Okay, so platform refers to the structure or vehicles on which remote sensing instruments are mounted. Okay, for example, in a ground base, okay, some of the common ones are the handheld devices, using tripods, towers, or cranes. key instruments that are ground-based are often used to measure the quantity and quality of light coming from the sun, or for close range characterization of object. Okay, for example, to study properties of a single plant or a small patch of a grass. Okay, and then in laboratory, maybe we can use remote sensing to identify different materials in leaf, okay, using multispectral camera or fluorescence camera. Okay, and then second platform, airborne. Okay, so these platforms were the sole non-ground based platforms for early remote sensing work. Okay, so for example, by using an airplanes, okay, or aircraft, okay, we can mount the sensors, the camera, okay, to capture the image. And then we have for satellite platform. Okay, so this platform is the most stable platform, which is a spaceborne. Okay, so basically by having different sensors attached to the satellite to capture the image for Earth monitoring. Key basic of remote sensing. So the remote sensing involves the measurement of energy that is reflected or emitted from objects without coming into contact with the objects. Okay, we call this energy as electromagnetic energy that travel through space as electromagnetic waves. Okay, so you can see the diagram. So each object, okay, examined by the remote sensing reflects a unique spectrum of wavelengths. Okay, so the percentage of reflected EM wave recorded by the sensor is called reflectance. Okay, the reflectance value is unique to different types of plant material or even condition of the plant. So that's why we can use the reflectance value to differentiate between different crops, different conditions of the crop, whether the crop is healthy or unhealthy, whether the crop is having stress. Okay, so as for the interaction of this electromagnetic energy, okay, when this energy, for example sunlight, strikes an object or hit an object, there are four things happen to this energy. Okay, we have transmission, okay, reflection, absorption, and then scattered. Okay, so transmitted is like a sunlight through a glass window. As for the reflection, like a mirror reflect your image, and then for absorption, like a sun bather soaking up the rays, and they're scattered when the wave is bounced in a random direction. Okay, this is might be due to the rough surface. Remote sensing can be divided into two types, okay, passive and active. Okay, a passive remote sensing detects electromagnetic wave from the sun that have been reflected off the surface of the earth, while for active remote sensing, it involves a radar system which transmit electromagnetic wave at the target and analyze waves that are reflected back towards the radar. Okay, in simple words, passive sensing use sunlight as the main energy, but on the other hand, active sensing has its own source of energy.